Welcome everyone. I'm so glad to have you all to the fifth episode of Rendezvous with the Stalwarts, the show where we discuss the journey of stalwarts in our profession and talk with them about their experiences, projects, and their vision for the future of our industry. I'm Daniel Couture, your host for the show, and in today's episode, it is an honor to be speaking to Charlie Thornton. Charlie is one of the most preeminent structural engineers and educators in the world. He served as chairman of Thornton Tomasetti until 2004 and serves as an advisor to the Thornton Tomasetti board of directors. Charlie has been involved in the design, construction, and analysis of projects worldwide, including hospitals, arenas, high rise buildings, airports, transportation facilities, and special structures. Charlie has led the structural design of some of the world's most significant structures, including two of the tallest, Taipei 101 in Taiwan and the Petronas Twin Towers in Kuala Lumpur. He is also currently the chairman of Charles Thornton and Company, a management and strategic consulting firm. So, without any further ado, let's move in straight to our conversation with Charlie Thornton. Welcome, Charlie, on today's episode of Rendezvous with the Stalwarts. I'm so excited and honored for having this conversation with you today.
Thank you. It's great to be here.
So, Charlie, I'm quite interested to know more about your front and back cover from your beautiful book, A Life of Elegant Solutions, followed by also knowing the story behind what inspired you to get into civil engineering during your growing years and then pursue a specialization in structural engineering.
So when I stepped down in 2005 from
Okay.
Thornton Tomasetti by design, we transitioned the ownership over 10 years from 95 to 2005.
Okay.
And everybody started saying to me, when are you going to write the book? And I said, I'm working on it right now. And the title of the book is Charles H. Thornton, A Life of Elegant Solutions.
Yes.
And if you know anything about the term elegant solution, it's a mathematical term. It's
Yes.
not a fashion term. And it was invented during Napoleonic years in France. And they used to have mathematics contests
Yes.
instead of beauty contests.
Yeah.
And one of the winners was Sophie Germain for solving some sort of a Laplacian fourth order differential equation. And it was called an elegant solution, which is pretty cool.
Yeah. Yeah.
And my wife has an MBA from UCLA. And when we bought our first sailboat, I said, what are we going to name it? And she said, well, in mathematics and in computer program, if you come up with the best algorithm, it's called an elegant solution. So why don't we name our first boat Elegant Solution 1, and then we had Elegant Solution 2 and Elegant Solution 3. And I've been sailing all over a lot of places. And when I was in Nantucket, in New England, somebody would always come by in a dinghy and say, by any chance, is there a mathematician on board? They knew. They knew.
Yeah.
So it's a great term. And basically, people always wanted to know exactly the questions you're asking me. How did you do it? How did you get there?
Yes.
What are the
Yes.
steps it takes to do that?
Yeah.
And
Yeah.
it's not an engineering book. It's a book about life.
Yes. Yes. You have penned down your entire experience over the years.
And I suggest to anyone who tells me they bought the book, I said, let your wife read it first or your husband read it first, because it kind of lets your spouse know kind of why you do what you do.
Yes, yes. So then what inspired you to get into civil engineering and then pursue a specialization in structural engineering?
I grew up in New York City. My
Okay.
father was a bricklayer.
Okay.
He was kicked out of grammar school in the 7th grade as an incorrigible juvenile delinquent. He thought he was an orphan. His father had died when he was 1. His mother had deserted the family.
Okay.
So he was being raised by 2 spinster Irish aunts. His family came from Ireland in 1840. They fought in the Civil War, and they were all masons. They were bricklayers.
Okay.
So all my relatives in the Bronx on my father's side were all bricklayers.
Okay.
On my mother's side, my grandfather was a master cabinet maker. carpenter.
Yeah.
And so it was sort of in my blood. So I started working at 14 as a bricklayer, 15 as a carpenter's apprentice, 16 as a transit man, rod man on a tunnel job. 17, I walked high steel on a 42-story steel frame building in New York City. And then at 17, 18, I worked on the foundations of the Chase Manhattan building, which were 80 feet deep.
Yes.
So, and then I went to Manhattan College and I just fell in love with it. Civil engineering, then structural engineering, and then in graduate school, it was really mostly mathematics and applied mechanics at NYU.
Okay. I'd like you to share about your special bond, friendship, and trust that you possess with Richard Tomasetti right from your college years to both of you deciding to purchase Lev Zetlin Associates and founding Thornton Tomasetti. And what was the goal or roadmap that you and Richard had in mind, both for Thornton Tomasetti and bringing a revolution in our industry? Right after you both formed a special partnership together.
He was 2 years behind me at Manhattan College.
Okay.
And he pledged for my fraternity when I was a senior. He was a sophomore.
Okay.
And he became president of the fraternity.
Okay.
And then he followed me to NYU and he did his master's degree under my thesis advisor, Dr. Charles Bernstein.
Okay.
Then he went off to electric boat and was designing deep submersibles after the Thresher submarine sank in like 66. And we were starting the American Airlines Hangar, which we won in 1968 when I was 28.
Yes.
And I needed an analyst that could figure out the buckling of a hyperbolic paraboloid made out of light gauge long span decking.
Okay.
And we hired a guy named Ashvin Shah, who had a master's degree from Berkeley. And he and Richard basically, no one had ever done it before. The orthotropic buckling of a light gauge metal shell, because the deck was 7.5 inches deep, 2 feet wide, and it spanned about 50 feet, but it had the curvature of a high par.
Yes.
And if you can get the curvature of the high par right, it will not buckle, whereas a flat plate will.
Yes.
So Ashvin and Richard basically came up with a solution that showed, and if you show a picture of the roof structure, the American Airlines hangar, I can kind of describe what it is.
Yes.
But we calculated that high par would buckle at 13,000 pounds per foot. A high par has tension in one direction and perpendicular is compression. And it's a beautiful form because it's generated by straight lines. But the fact of the matter is, when you go on the diagonal, they're parabolas.
Yes.
And we built a model at Inland Ryerson's plant in Milwaukee, and we load tested it by putting a vacuum load on it. So we put a uniform load on the horizontal projection, and lo and behold, it buckled at 13,000 pounds per foot. We were driving piles for the foundations, and the steel was all ordered, and we weren't really quite sure at what load it was going to buckle. In 68, Dr. Zetlin was asked by American Airlines, who's going to sign and seal the drawings in California? And he said, Charlie, he's going out next week to take the test. So I had to pass it.
Good.
I ended up with 27 licenses in states and District of Columbia.
That's great.
So I call trial by fire. I call it being thrown in the deep end of the pool. Certain firms do that. Zetlin did it. Yes. It makes you grow real fast.
Yes.
And if you go in the pool and you don't come up, they don't really care.
Yeah.
So I was very lucky. Just when I joined Lev Zetlin Associates, I was 21, and they were just starting on 14 pavilions at the New York World's Fair.
Yes.
And I did the Travelers Pavilion, which was a bunch of boomerang steel shapes. But the one that really tickled my curiosity was the New York State Pavilion, which I sent you pictures of.
Yes.
And those 280-foot tall circular slip form cores had significant tension. So we post-tensioned them inside the shell. We did
Yes.
vertical post-tensioning, which is a
Yes.
really clever way to make a structure not have tensile stresses.
Yes. Yes.
So I worked on 14 of them, and just about when I started my PhD thesis in 64, I was finished with the projects because it was the 64, 65 World's Fair. I got my PhD in 66, had 13 offers from aerospace firms because Kennedy said we were going to the moon.
Yeah.
Well, they all offered me 30% more than a consulting engineering firm, but I knew I'd never be president or owner of Boeing.
Yeah.
So I decided that I'd go back and take a fling at consulting in one of the toughest markets in the United States, the New York
Yeah.
engineering market.
Yes.
As
Yes.
they say, if you can make it in New York, you can make it anywhere. Great place to work,
Yes. Yes.
great creativity.
Yes.
So Richard and I were friends, and we went through the period where Lev Zetlin sold the company to a New York Stock Exchange company called Gable Industries.
Okay.
He had a 5-year contract. He left after 3, and they basically offered me the opportunity to buy it.
Okay.
No money down, no personal guarantees, and a 5-year payout. And I turned around to Richard and I said, look, let's just do it 50-50. I need somebody to protect my flank. It's like
Yes.
marriage.
Yeah.
And if you know Richard personally, he's absolutely the total opposite of me.
Okay.
I'm a risk taker, and he doesn't take any risks.
Good.
So he became my anchor.
Yes. Yes. Yes.
I once repeated this story. I said, if Richard had taken over the company, it would still be 50 people. And if I had taken it over without him, I probably would be bankrupt. That's the way it works.
Yeah. Yeah. Yeah.
You need to have a partner that
Yes.
you
Yes.
trust.
Yes, definitely, definitely. You both share quite an interesting bond, and the vision that you both brought in with Thornton Tomasetti and where it has reached so far, it's truly inspiring.
Right. The key to succeeding in consulting engineering is every 5 years, you need to do a strategic plan.
Yes.
But before you do a company strategic plan, you better do a plan for yourself. Okay. And you should write down on a piece of paper what your goals are. 5 years, 10 years, 15, 20 years. Don't show it to anybody
Yes, yes.
because you're going to have to change it.
Yes, yes, yes.
But the
yes.
strategic plan for the company has to basically have buy-in from all the stakeholders. It's
Yeah,
not my
yeah.
plan. It's not Tomasetti's plan. It's their
Yes.
plan.
Yes.
And then you have to enable them to hit
Yes,
that
yes.
plan.
Yeah, yeah.
And we were very, very astute at watching markets. For example, we were very busy in the beginning in the 60s. Then the Arab oil embargo killed everything in the United States. So we went to Saudi Arabia. We went
Yes.
to Moscow. We did Corps of Engineers work in Saudi Arabia. We
Yes.
worked on King Abdul Aziz Military Academy. And then in 1978, the Hartford Coliseum roof fell down. And we were selected against 5 other big firms in New England. And we
Okay.
got the job. And I got the best compliment of my life because I went to the interview alone. And I know I was up against Wisjani Elsner, LeMessurier, Simpson,
Yeah.
Gumpitz, Hager, and who else
Yes.
knows. And after we finished the report in mid-78, I asked the city manager, why did you pick us? Why did you pick me?
Yes. Yeah.
He said, because you were the only one the committee thought the people of Hartford would believe. Very nice compliment.
Yes, 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 yes. Yeah.
And then it was the end of the Arab oil embargo recession, and we took off like a rocket in 79, 80. We did all those great projects like Battery Park City, all those
Yes.
high-rise buildings in the mid-80s, One
Yes,
Liberty
yes.
Place. And we
Yes.
really established a reputation for 2 things. Very, very optimized weight of buildings.
Yeah.
We had optimization programs. And most of my coursework at NYU was in the aeronautical department.
Okay.
And when you're in aerospace engineering, your structure has to fly.
Yeah.
Most civil engineers, they don't really think about minimum weight.
Yes.
But minimum weight means you reduce material, makes it more sustainable. And
Yes.
basically, it's not really right, but clients say, how much can you reduce the steel weight in this high-rise building? It has nothing
Yes.
to do with weight. It has to
Yes.
do with how much it's going to cost.
Yes. Yes. Yeah.
So anyway, it was a very, very successful relationship. And my strategic plan was to teach
Yes.
Cooper Union, Manhattan College, capstone courses,
Yes.
Pratt, Princeton, and Catholic U. And why was I teaching capstone courses? I was recruiting the low-hanging fruit. I hired Tom Scarangello, presently the chairman. I hired Mike Squazzini. I hired Wayne Stocks.
Yes.
Eventually we got Peter DiMaggio from Weidlinger.
Yes.
And every one of those people, when I hired them, I said, if you play the game the way we play the game, you will end up owning this company. And they did.
Yes.
A lot of firms, the founders, they stay around too long.
Yes.
And
Yes.
the young people have to be paid to
Yes.
buy you out. Now you're really
Yes.
giving them the bonuses, but they're the ones that are making it.
Yes.
So we
Yes.
did it from 1995 to 2005, and we got all our money out plus some residuals between 2005 and 2010. And that's
Okay.
when I started 5 new companies.
Yes. 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 We'll come to those companies later in the questions as we progress. Yes. Yes. So, Charlie, what were all the sacrifices and hard works on a personal level that you and Richard had to put in together to build up such a successful engineering firm that Thornton Tomasetti has reached in our industry today? Also, were there any strong founding principles or practices that you were trying to imbibe in the company culture at TT right from the start?
Yes. Number one, you have to retain your staff.
Yes.
If you lose your staff because you're not treating them well and they go to another firm, they end up becoming your competition.
Yes.
So my first goal was to maintain the staff, not let them leave, make them feel good, pay them more than anybody else would pay them,
Yes.
and give them opportunities to basically expand themselves.
Yes.
So in 1993, we started acquiring offices. First one was Chicago, was CBM. The second one was Ellis Ortana in Dallas. These were good firms, but the original owners were getting old. They were losing confidence, and they were firing the wrong people. They weren't keeping the replacements there because they had no intention of leaving. So we bought them for whatever they wanted. And what we did is, with our business development machine, we tripled the volume in 2 years in every office we acquired.
Okay.
But it didn't make any difference how much we paid Ellie Cohen or John Tanner or whoever.
Yes.
The
Yes.
company now has 50 offices worldwide.
Yes. Yes.
And as we started the transition, I said to the people in New York, we need 50% of the stock in the company in the hands of people outside of the New York office.
Yes.
Otherwise, it ain't going to work.
Yes. Yes.
And everybody owns the stock in the same company. It's not like some of these other structural firms that actually have separate profit centers and they compete against each other. That's about the stupidest thing you can do.
Yes. 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 Yes.
So it's a very, very strong company. We have probably 33% women engineers, 33%. And that's by design. And if you get a copy of their 2020 annual report, it's all about sustainability and diversity. And women have certain advantages over men, and men have certain advantages over women.
Yeah. Yeah.
We also, I know we're going to talk a little bit about the ACE Mentor program.
Yes. Yes.
What I did was, each time we acquired an office, I started ACE in that city. So ACE Chicago was the first really outside the New York metropolitan area. Then
Yes.
ACE Dallas. Then
Yes.
ACE Bridgeport, Connecticut. Then
Yes.
ACE Seattle. Then ACE San Francisco. And basically now it's got a major office in every city. And what's great is when either a husband or a wife gets transferred,
Yeah.
they our employee can move with the spouse,
Yes.
and they continue working for us, especially now with COVID remotely. So it's a fantastic way to grow a firm because you don't lose
Yes.
people who move away.
Yes. Yes. Definitely. Definitely.
Now, a lot of this was luck, timing.
Yeah.
I mean, let's take the number of arenas that we did. Bulls and Blackhawks in Chicago, Pepsi Center in Denver,
Yes.
Mighty Ducks Arena. A very famous structural engineer died in 1988, Dave Geiger,
Okay.
Geiger Berger, that did all those tensile structures. He was in his 50s. He had a heart attack.
Okay.
And I realized that the three big sports architects in Kansas City were hurting. They didn't have a go-to structural engineer.
Okay.
So I went out there with one of my assistants, and we met with two of them, and we got jobs. We got the two arena jobs in Chicago, Anaheim, within 2 weeks.
That's great. That's
You
great.
got to be in the right. And what we did is everybody else was doing 30-foot deep one-way trusses on 300-foot spans. We used the geometry. We used the geometrical form to cut the steel from 35 pounds a square foot to 17 pounds. And we have never been afraid of means and methods.
Yes.
Don't believe the contracts. Architects and engineering organizations try to talk you out of getting involved in means and methods. That is absolutely BS. Okay.
Yeah.
You
Yeah.
have to help the contractor if you want to succeed.
Yes. Yes.
All the
Definitely.
big contractors on all of those big arena projects and football stadiums and baseball stadiums, they said to the owner, you got to hire Thornton Tomasetti because we'll get the job done on time. If you hire
Yes.
X, Y, and Z, we can't guarantee we'll open it. We got paid
Yeah.
a big fee on Soldier Field for finishing it in 19 months.
Yes.
So, you got to be aggressive.
Yeah. Yeah.
You got to get enough money to do the right job.
Yes. Yes.
That's the one thing that Lev Zetlin taught me. He
Good.
knew how to get the right fee to do the right job and do something different.
Yes. Yeah.
And he was actually a pretty risky guy, but we made all of his ideas happen.
Yeah. Quite interesting. Quite interesting.
Yeah, it's a fascinating relationship.
Yes. Yes. Charlie, you have seen through the entire design processes and how have they changed over the past 50 years in your career. I'd like to know your views on which of the changes in our design processes or systems have been detrimental for us and which are the changes that our industry should be working on to develop or improve more in the coming years.
Well, number one, technologically, the two greatest technologies were Excel spreadsheets
Yes.
and obviously digital computers.
Yeah.
And I got a leg up because when I started at NYU in 61, nobody at LZA had ever had a computer course.
Yes.
And I went from no computers at Manhattan College to all computers at NYU. So I had a leg up on everybody else because I knew how to program Fortran.
Uh-huh.
And I decided I wasn't going to do that for the rest of my life.
Yes.
But when we did a project like the Petronas Towers, Len Joseph, one of the smartest engineers I've ever worked with, he did an elastic spreadsheet. And what I mean by that is Caesar Pelli did not know the angles as the building started to go in at the top.
Yes.
So we just set them up as variables
Okay.
because prior to the large elastic spreadsheet, and if an architect changed the top of the building or they added 2 floors, you had to run all the load takedown by hand again.
Yes.
we did a project in Sydney, Australia with Cone, Pedersen, Fox, and they changed the top of the building at the last minute. And it took us in New York, working with an Australian structural firm, took us 3 days to redesign the whole thing. And Len Joseph flew to Sydney and delivered the revised drawings in 3 days.
That's great.
That's what you got to do.
Yes, yes.
Because the problem is when they change the top of the building, you may get paid and you may not get paid. Depends on who instituted the change.
Yes, yes.
If the architect instituted it, the expression is you're going to suck hind tit. I think the codes have gotten much too complex.
Yes.
Here's my ACI code from 1958. See it?
Yes.
See it?
Yes.
Everything I designed using this is still standing.
Yes.
Everything I designed without a wind tunnel using just 0.000256 times velocity squared is still standing.
Yes.
Why do we have all this shit from ASCE 7?
Yes.
Right?
Yeah.
It doesn't make the building any better, in my opinion.
Yes.
It for people who don't have the experience, and let me make another statement. If you can't do the first pass of the calculations on any project by hand, you're not a very good structural engineer. If you have to put it into a three-dimensional model, you're going to lose money for your firm.
Yes.
You're going to get involved in the diaphragm. Is it flexible diaphragm or is it non-flexible diaphragm? And so when we did Miglin Beitler in Chicago, which was 2,000 feet,
Yes.
number one, I wouldn't let them do anything but two-dimensional analyses in north, south, east, west. And Bob DeCenza, who became president of the company, he did it all by hand.
Okay.
And we tracked the mass so that we knew whether we needed the TMD in it long before we talked to RWDI or Cermak Peterka.
Okay.
And Len Joseph will tell you that on the Petronas Towers, based upon a couple of 24-hour flights, my hand calculations for Petronas were within 10% of the final stresses.
Yes. Yes.
After $1 million worth of three-dimensional SAP 2000 models. And then the other thing is our failure analysis work. It instantly taught us how to do what I call perturbation techniques.
Yes.
Nonlinear pushover, performance-based design is basically a perturbing of the structure in incremental iterative steps, and you can get convergence in a nonlinear structure. And I learned that in my PhD thesis. Because I was solving hundreds of nonlinear simultaneous equations.
Yes. Yes. Yes.
But because it was a physical problem, I could tell when it was an incorrect convergence.
Yeah. Yeah.
Right? Whereas a mathematician trying to solve nonlinear equations that don't relate to a physical issue, they don't have a clue what they're getting.
Yes. Yes.
But anyway, I mean, it was. My advice to any engineer is never say no to your boss. They ask you to do something, admit that you either know it or you don't know it. And if you don't know it, say, I'll take any assignment you want, but you got to give me the right person to work with.
Yes. Yes.
And who is that person? And then I tell them who that person is, somebody who's done something that I haven't done.
Yes. Yes.
And the worst thing you can do is not. Thornton Tomasetti was set up as a studio. Anybody that didn't know how to do something was rewarded for coming and saying, I don't know how to do this. How do I do this?
Yes.
And they were not rewarded when they covered it up that they didn't know what they were doing and they screwed it up.
Yeah. Yeah.
And we had a guy, we had Len Joseph, and we had a person in every office that was sort of the mentor, the big brother or the big sister.
Yes.
You need help.
Yeah.
I mean, I don't know about you, but when I got my bachelor's degree, I thought the world was linear.
Yes.
And then I got my master's degree and I took all these mechanics courses and I realized, man, I don't know anything. So I decided I keep going.
Yeah. Yeah.
My theory of going from 20 to 30 to 40 to 50 is In your 20s, you're learning
Yes.
and you're a sponge and you absorb everything. And if you don't understand it, you ask.
Yes.
In your 30s, you start developing relationships with clients because you try to pick out who within the architectural firm, who within the contractor is the brightest star, and you hitch your wagon to that star
Yes.
and you take them up. You don't try to develop relationships with the slugs, the people that aren't going to make it, and you can tell them immediately. You can tell the people that are going to make it and the people that aren't.
Yes.
And then in your 40s, you better start owning something.
Yes.
If you've been there 20 years, 18 years, and you're not a partner,
Yeah.
leave.
Yes. Yes.
And in your 60s, 50s, and 60s, do something else.
Yes.
Get the hell out of there. Get out of the way.
Yeah. Yeah.
So how did I get out of the way? In 1998, I decided we were going to buy a company in Washington, D.C. I lived on the water in Connecticut, had my big sailboat in the backyard. And I came down and I decided we were going to buy this firm. Nobody else wanted to move to Washington. I wanted to open the federal market. So I bought 17 acres with 3,000 feet of shoreline on Chesapeake Bay. And I left New York. I ran that office for 5 years. And I went in on Tuesday at noon. I came home on Thursday at noon to beat the Washington, D.C. traffic. And I really didn't like it.
Yeah.
So then I decided to start 4 new companies so I could really be busy.
Yeah.
And one of them is the project you wanted me to talk about, which is in
Yes.
Bangalore, India.
That brings us to the end of part 1 of our conversation with Charlie. In the second part, we'll be discussing with him the design stories of the tallest buildings around the world, his expertise in failure analysis, and some of his innovative work in our profession. See you all in the second part of our conversation with Charlie.